Think about it. Every single time you drive, you're using this incredible system that you probably never even give a second thought to, but it's easily one of the most important safety features on your entire vehicle. So today, we're going to dive into this amazing piece of engineering, your car's brakes. It sounds almost impossible when you put it that way, right? I mean, how does that one little push from your foot create enough force to stop thousands of pounds of steel moving at highway speeds? Well, that's the big question we're going to answer. So, to really get how brakes work, we have to start with a little bit of physics. Because here's the thing, stopping a car isn't about making its speed just disappear. It's all about changing its energy from one form to another. Okay, so any object that's moving has something called kinetic energy. And the rule is simple. The heavier it is and the faster it's going, the more kinetic energy it's packing. So to bring that car to a stop, all of that energy has to go somewhere. It can't just vanish. And that right there, that's the secret sauce. Brakes don't destroy energy, they convert it. It's a brilliantly simple idea, and it's what makes this whole thing possible. So here's the conversion process in a nutshell. All that kinetic energy, the energy of motion, gets transformed into heat energy. Yep, that's right. Your brakes are basically just really sophisticated heat generators. They create a ton of friction at the wheels, and that friction turns all that forward momentum into pure, raw heat that then radiates away. Okay, so we need a ton of friction to create all that heat. But how in the world does your foot generate that kind of force? Well, it doesn't. That's where the absolute magic of hydraulics comes in, turning your effort into something way, way more powerful. So here's what happens the second your foot touches that pedal. You're not actually connected to the brakes themselves. What you're doing is pushing a small piston inside something called the master cylinder. That puts brake fluid under incredible pressure. And because you can't really compress a liquid, that force shoots through the brake lines instantly and evenly to all four wheels of the car. And that's the absolute genius of it. The way the hydraulics are designed, that small bit of force from your foot gets multiplied into a massive clamping force at the wheels. It's what gives any of us the power to bring a heavy machine like a car under control. But of course, in modern cars, it gets even better. There's a device called a brake booster, and it uses engine vacuum, or a little electric motor, to give your foot an extra shove. That's the reason your brake pedal feels so firm, but is still super easy to press. It doesn't feel like you're trying to leg press a building, and that's why. All right, let's follow that force. We've sent all this powerful hydraulic pressure shooting down the lines. Now what? Now we get to the business end of things, down at the wheel, where the action really happens. When you get down to the wheel itself, you're pretty much going to find one of two main designs that do all the heavy lifting, the really common disc brake or the older but still very useful drum brake. So what's the difference? Well, with a disc brake, you have pads that squeeze a spinning disc, which we call a rotor. It's kind of like clamping down on a spinning plate with your hands. Drum brakes do the opposite. They have brake shoes that push outwards against the inside of a spinning drum. Now, the big advantage for disc brakes is that they're out in the open air, so they get rid of heat way better. And that's a huge deal, especially on the front wheels, which do most of the work when you stop. And when I say heat, I mean heat. During a really hard stop, a brake rotor can easily get over 500 degrees Celsius. That's more than 900 degrees Fahrenheit. That's not just warm, that's literally cook a pizza hot. It just goes to show you the insane amount of energy being converted every time you stop. But, it's not just about raw mechanical and hydraulic force anymore. Nowadays, you've got this whole suite of brilliant electronic systems that work as a team with the mechanical parts to make stopping safer and way more controlled than ever before. So picture this. You're in an emergency. You have to slam on the brakes to avoid something in the road. Besides hitting the object, what's the single biggest danger in that moment? It's your wheels completely locking up. And here's why that's so terrifying. A tire that's skidding has lost its grip. It's just sliding. And if your front wheels are sliding, guess what? You can turn the steering wheel all you want, but you have zero steering control. You're not driving anymore, you're just along for the ride. And that is exactly why the anti-lock braking system, or ABS, was invented. It uses sensors on each wheel to know the exact moment a wheel is about to lock up. And when it senses that, a computer instantly starts pulsing the brake pressure to that specific wheel, releasing and reapplying it over and over.
And this is where you see just how superhuman this system is. You know, the old advice was to pump the brakes yourself, but even the best driver can only do that maybe 2 or 3 times a second. An ABS computer can pulse that brake up to 15 times every single second. It keeps the wheel right on the edge of locking up, which gives you maximum stopping power while still letting you steer. It's a game changer.
And ABS isn't working alone. It's got a team. Electronic brake distribution is constantly adjusting the brake force between the front and rear wheels to keep the car stable. And brake assist is really clever. It can tell from how fast you hit the pedal that you're in a panic, and it'll automatically apply 100% brake force for you, even if your foot doesn't go all the way to the floor. Okay, so now that we're all amazed at the engineering, let's talk about our part in all this. Because brakes wear out, that's just what they do, and keeping them in good shape is one of the most important responsibilities you have as a driver. Your car is actually pretty good at telling you when its brakes need help. You just have to listen and feel. Are you hearing a high-pitched squeal, a deep, horrible grinding? Do you feel a vibration through the pedal? Or does the pedal feel kind of soft and spongy? If your car pulls to one side when you brake, that's another huge red flag. Whatever you do, don't ignore these signs. And if you were to look at the parts, the difference is night and day. A healthy brake pad has a thick layer of friction material. When it's worn out, it's paper thin. Your brake fluid should be a nice, clear amber color, not dark and murky. And your brake rotors should be smooth, not all carved up with grooves. This is why getting them checked regularly is so critical. When you really think about it, it's just this beautiful, elegant system. It's a perfect mix of basic physics, clever hydraulics, and incredibly smart electronics, all working together seamlessly just to keep you safe. It's a piece of everyday engineering that is truly extraordinary. And all this just makes you wonder, right? We've gone from simple mechanical clamps to electronic systems that can react faster than a human ever could. So where do we go from here? As these systems get even smarter and more predictive, what's the next challenge they're going to solve? Will your car's brakes soon be able to stop a problem before you even know the problem exists? It feels like we're just getting started.